Let's explore some potential causes for a 100 amp 3-phase disconnect that consistently blows a 100 amp fuse on phase A, even though the phases typically carry only 50 to 60 amps each. We will also look at some troubleshooting steps to take. Firstly, consider an intermittent ground fault. Check for loose connections or insulation damage in the disconnect or panel circuitry, specifically on phase A. A megameter can be used to test the resistance to ground, which may reveal a hidden fault. Secondly, harmonic distortion might be the culprit. AC condensers and walk-in cooler condensers are known to generate harmonics. These harmonics can distort the current waveform and lead to premature fuse failure. It is worth considering using a power quality analyzer to measure the harmonic levels in the system. Thirdly, overloading could be the issue. Even though the phases normally carry 50 to 60 amps, there might be periods of high load on phase A. Monitor the current on all three phases to ensure that phase A is not exceeding its rated capacity. Use a clamp meter to observe current levels over time and catch any unexpected spikes. Fourthly, it's possible that the 100 amp fuse on phase A is simply defective. Try replacing the fuse with a new one of the same rating and type to rule out a faulty fuse as the cause. Fifthly, other equipment connected to phase A might have intermittent issues or overloads. Check for any other equipment connected to phase A that may be causing the problem. Isolate and test each piece of equipment individually to identify the source of the blown fuse. Now let's outline some troubleshooting steps. Firstly, inspect the disconnect panel. Carefully look for signs of arcing, loose connections, or any visible insulation damage. Pay close attention to the connections on phase A. Secondly, test for ground faults. Use a megameter to check the resistance to ground on phase A. A low resistance reading indicates a ground fault. Thirdly, monitor current. Use a clamp meter to monitor the current on all three phases over time. This will help you identify any overloads or imbalances that could be causing the fuse to blow. Fourthly, test the fuse. Replace the 100 amp fuse on phase A with a new one of the same rating. If the new fuse blows as well, then the problem is not with the fuse itself. Fifthly, isolate equipment. Disconnect one piece of equipment at a time from phase A and see if the fuse still blows. This process of elimination will help you identify the specific equipment that is causing the problem. Sixthly, check harmonics. Employ a power quality analyzer to measure harmonic levels on phase A. High harmonic levels could be the reason for the fuse failures. Also, it is important to ensure that the disconnect is properly sized for the load it is serving. Using fuses with the correct rating and characteristics for the equipment being protected is critical. Keeping the disconnect panel clean and free of debris helps to prevent overheating and other issues. Regularly have the electrical system inspected by a qualified electrician to identify and address any potential problems before they lead to failures. Let's delve a bit deeper into each of these potential causes and troubleshooting steps. When checking for intermittent ground faults, it's important to understand how a megameter works. A megameter, also known as an insulation tester, applies a high voltage DC current to the circuit being tested and measures the resistance. A low resistance reading indicates a path for current to flow to ground, which means there is a ground fault. When using a megameter, always disconnect the circuit from the power source and any sensitive electronic equipment. Follow the manufacturer's instructions for the megameter carefully. When investigating harmonic distortion, remember that harmonics are multiples of the fundamental frequency of the AC power supply, which is typically 60 Hz. Common sources of harmonics include electronic devices with nonlinear loads such as variable frequency drives, uninterruptible power supplies, and energy-efficient lighting. A power quality analyzer can measure the amplitude and frequency of each harmonic component in the current and voltage waveforms. High levels of harmonic distortion can cause overheating of electrical equipment, increased energy consumption, and premature failure of components like fuses and transformers. If high harmonic levels are detected, consider installing harmonic filters to mitigate the problem. When monitoring current, it's crucial to use a clamp meter that is capable of measuring true RMS current. True RMS meters accurately measure the current of non-sinusoidal waveforms, which are often present in circuits with harmonic distortion. A standard average reading clamp meter may not provide accurate readings in these situations. Monitor the current on all three phases simultaneously to identify any imbalances. Significant current imbalance can indicate a problem with the load or the power supply. When testing the fuse, visually inspect the blown fuse for any signs of damage, such as a melted element or a cracked casing. A blown fuse can sometimes provide clues about the cause of the overcurrent. However, a visual inspection is not always reliable, so it's always best to replace the fuse with a new one of the same rating and type. Ensure that the replacement fuse has the correct interrupting rating for the application. The interrupting rating is the maximum amount of current that the fuse can safely interrupt without causing an arc or explosion. When isolating equipment, start by disconnecting non-essential loads first. If the fuse continues to blow after disconnecting several loads, focus on the larger and more critical pieces of equipment. Before disconnecting any equipment, ensure that it is properly de-energized and locked out to prevent accidental energization. Follow all applicable safety procedures when working with electrical equipment. When checking harmonics, a power quality analyzer will typically display the total harmonic distortion or THD, which is a measure of the overall level of harmonic distortion in the system. A high THD value indicates a significant amount of harmonic distortion. The power quality analyzer can also provide a breakdown of the individual harmonic components, such as the third, fifth, and seventh harmonics. This information can help you identify the sources of the harmonic distortion. When ensuring the disconnect is properly sized, consult the National Electrical Code, NEC, or local electrical codes for guidance. The NEC provides specific requirements for the sizing of disconnects and other current protection devices based on the load they are serving. Consider the continuous and non-continuous loads connected to the disconnect. The disconnect should be rated to handle the total load current without overheating. When using fuses with the correct rating and characteristics, select fuses that are specifically designed for the type of equipment they are protecting. For example, motor circuits typically require time delay fuses that can withstand the high inrush current that occurs when a motor starts. Electronic equipment may require fast-acting fuses that can quickly interrupt overcurrents to protect sensitive components. Consult the equipment manufacturer's recommendations for the correct fuse type and rating. When keeping the disconnect and panel clean, regularly inspect the inside of the disconnect and panel for dust, dirt, and debris. Use a vacuum cleaner or clean, dry cloth to remove any contaminants. Avoid using compressed air, as it can blow contaminants into sensitive components. Ensure that all connections are tight and free of corrosion. Loose connections can cause overheating and voltage drop. When having the electrical system inspected regularly, schedule regular inspections by a qualified electrician to identify and address any potential problems before they lead to failures. The electrician should inspect all electrical equipment, including disconnects, panels, wiring, and grounding systems. The electrician should also perform insulation resistance testing, thermal imaging, and other diagnostic tests to identify hidden problems. Keep a record of all inspections and repairs to track the condition of the electrical system over time. In addition to these steps, consider the environmental conditions in which the disconnect is located. High temperatures, humidity, and corrosive atmospheres can accelerate the deterioration of electrical equipment and increase the risk of failures. If the disconnect is located in a harsh environment, take steps to protect it from the elements, such as installing a weatherproof enclosure or applying a protective coating. Also, be aware of any changes in the electrical load or equipment connected to the disconnect. Adding new equipment or increasing the load on existing equipment can overload the circuits and cause the fuse to blow. Always consult a qualified electrician before making any changes to the electrical system. To reiterate, when a 100 amp fuse keeps blowing in a 3-phase disconnect, even though the current draw is within the normal range, a systematic approach to troubleshooting is essential. Begin with a thorough visual inspection of the disconnect and panel, checking for loose connections, damaged insulation, and signs of overheating. Next, test for ground faults using a megameter, paying close attention to phase A, where the fuse is blowing. Monitor the current on all three phases over time to identify any overloads or imbalances. Replace the fuse with a new one of the same rating and type to rule out a faulty fuse. If the problem persists, isolate equipment by disconnecting loads one at a time until the fuse stops blowing. Check for harmonic distortion using a power quality analyzer, especially if AC condensers or walk-in coolers are connected to the circuit. Ensure that the disconnect is properly sized for the load and that the fuses have the correct rating and characteristics. Keep the disconnect and panel clean and free of debris, and schedule regular inspections by a qualified electrician. By following these steps, you can effectively diagnose and resolve the issue of a repeatedly blowing fuse and prevent future electrical problems. Furthermore, consider the age of the equipment. Older disconnects and panels may have deteriorated insulation or worn components that can contribute to electrical problems. If the equipment is old or in poor condition, it may be necessary to replace it. When replacing electrical equipment, choose high-quality components that are designed to withstand the demands of the application. Also, ensure that the new equipment is properly installed and grounded according to the NEC and local electrical codes. Finally, remember that electrical work can be dangerous. If you are not comfortable working with electrical equipment, it is best to call a qualified electrician. Always follow proper safety procedures when working with electricity and never take risks. By following these additional tips, you can help ensure the safety and reliability of your electrical system. Let's summarize the key points. Firstly, intermittent ground faults are a common cause of fuses blowing. Secondly, harmonic distortion from AC condensers and walk-in coolers can also cause fuse failures. Thirdly, overloading, even for short periods, can exceed the fuse's capacity. Fourthly, a faulty fuse itself may be the culprit. Fifthly, other equipment connected to phaser could be causing the problem. When troubleshooting, remember to inspect the disconnect and panel, test for ground faults, monitor current, test the fuse, isolate equipment, and check for harmonics. Also, ensure that the disconnect is properly sized, the fuses are correctly rated, the equipment is kept clean, and the electrical system is regularly inspected. By systematically addressing these potential causes and following the recommended troubleshooting steps, you can effectively diagnose and resolve the issue of a repeatedly blowing fuse and maintain a safe and reliable electrical system. Always prioritize safety when working with electricity and consult a qualified electrician if needed. And remember, prevention is key. Regular maintenance and inspections can help identify and address potential problems before they lead to failures. This includes checking for loose connections, cleaning equipment, testing insulation resistance, and monitoring current levels. A well-maintained electrical system is a safe and efficient electrical system. Electrical safety is of paramount importance. Before undertaking any electrical work, ensure that you are familiar with and adhere to all relevant safety regulations and guidelines. Always energize the circuit before working on it, and use appropriate personal protective equipment such as insulated gloves and safety glasses. If you are unsure about any aspect of the work, consult a qualified electrician. Electricity can be dangerous, and it is essential to take precautions to protect yourself and others. It is also a good practice to document all troubleshooting steps and findings. This documentation can be helpful for future reference and can also assist a qualified electrician if you need to call one. Include details such as the date and time of the troubleshooting, the steps taken, the measurements obtained, and any observations made. A well-documented troubleshooting process can save time and effort in the long run. Finally, remember that electrical systems are complex and can be affected by a variety of factors. While this guide provides a comprehensive overview of potential causes and troubleshooting steps for a repeatedly blowing fuse, it is not a substitute for professional expertise. If you are unable to resolve the issue yourself, or if you are concerned about the safety of the electrical system, it is always best to call a qualified electrician. A qualified electrician has the knowledge, skills, and equipment to diagnose and repair electrical problems safely and effectively. They can also provide valuable advice on how to maintain your electrical system and prevent future problems. In summary, addressing a repeatedly blowing fuse requires a systematic approach that considers various potential causes, involves thorough troubleshooting steps, emphasizes electrical safety, and may necessitate the expertise of a qualified electrician. By following these guidelines, you can effectively resolve the issue and ensure the safe and reliable operation of your electrical system.